Hey guys, it's Miss Nelson. Today you guys are going to be doing notes over equivalent ratios. So you guys know what a ratio is because we've talked about this before. A ratio is a multiplicative comparison of two quantities describing the same attribute or the same thing. So we're going to be talking about the same thing and comparing them in a form of a ratio. So if we look at this, it says there are three ways to write a ratio comparing A to B. Now, A and B are just placeholders. They are eventually going to be numbers whenever you are using them in context with doing problems. But I just gave you the generic A and B to show you the three different ways that we can write it. So we can write A and then the word to and B. We can write it with symbols. So A to B, and we can also write it, remember a ratio is in fact a fraction, so we can also write it as A over B. Now, with your ratios, remember, you always need to simplify your ratios. So you are probably going to start with a ratio that is unsimplified, and then we're going to divide it and get it into an equivalent, simpler form. So it says, in order to find equivalent ratios, you will multiply your ratio by a number to make it larger. So if we're making it larger, we're going to choose the same number and multiply it by a value of 1 to make it larger. Or if we want to make it smaller, again, you're reducing those fractions by dividing both of those numbers by the same number. So if we look at example 1, it says there are 12 males and 18 females on the swim team. Which ratio in the box does not represent the situation? Justify your answer. Okay. So I'm going to start with my original. My original is 12 over 18. So I know automatically that 12 over 18 does match it. So I'm done with that one. So I'm going to simplify this 12 over 18. And I'm going to see if I have any fractions because I have some fractions in here that are smaller than 18. So I'm going to simplify them and see if I can cross any of these out. So if I divide both of these by 2, I get 6 over 9. So I come back and look over here. 6 over 9 is a fraction, so it works. So I'm going to cross it out. I'm going to keep simplifying. Divide it by 2 again, and I get 3. Oh, no, I'm sorry. I cannot divide by 2. I was wondering what I was saying. I'm going to divide by 3. Excuse me. So that's going to give me 2 over 3, so 2/3. That is 1. Now, if I come over here, I'm going to come back to this 6/9 for just a minute. 6/9. If I'm trying to get it to be 60 over 90, I know that I can multiply both of these by 10. This is your example of when you're going to multiply by a number to make it bigger. Since 6/9 turns into my 6/90, I can cross that out. So if I keep going, let's see, I have 30 over 45. So if I'm going to take one of these that can go into 45 fairly easy. So I'm going to take my 2/3. And remember, all these fractions that I'm writing are all equivalent. They are just in different forms. So I'm going to see what I can do with my 2/3 to get it to be something over 45. I know that 3 times 15 is 45. So if I multiply 2 times 15, I'm going to get 30/45. That is also 1. I come over here. I'm going to go back to my 12/18 for just a minute. I'm going to divide it by something else. What if I divided it by 3 instead of 2? That's going to give me 4, 6, which is also another answer. And I'm left with my 24 over 36 and my 3/4. So if I start with my original 12/18, what can I multiply it by to get it to be something over 36? I'm going to multiply it by 2. And 12 times 2 is 24. So that one also works. So out of all these small fractions that we got, I got 4/6, I got 2/3, I got 6/9. None of those were 3/4. So 3/4 is a ratio that does not fit in with the rest. So I need to justify. So I'm going to write and say 3/4 is not equivalent to 12/18. Okay, because out of all those numbers that we simplified and increased and got larger numbers, 3/4 was never one of those numbers that we could get. I can never get, if I try to multiply and get this 4 times something to get an 18. 4 times something is never going to be 18 unless it is a fraction. But if I multiply the 4 times the same number, I know that this 3 right here times 4 will get me my 12. And 4 times 4 is not 18. Therefore, you know that that's the fraction that is not equivalent. Okay? So let's look at number 2. It says James has a large collection of toy cars and trucks. The ratio of cars to trucks is 2/5. Which fraction best represents the same ratio of cars to trucks in James's collection? Okay, so let's start here, and I'm going to figure out what I need to multiply my 5 by to get each one of these denominators here. Okay, so for example, I know that 2/5, I can multiply my 5 by 100 to get a 500. So then I have to multiply this by 100, and I should get 200 as my numerator. But I have 20 here, so that means that that does not work. Over here, I know that I can multiply, if I'm not sure, I know that I can multiply my 2/5 times something to get 250. So I know that 50 times 5 is going to give me 250. So 50 times 2 should give me a 100. 102 is not 100, so that is gone. I'm going to take it again, my 2/5 times something, and I want to get a 75. I know that 5 times 15 is 75, so I also multiply it by my numerator, which is going to give me 30 over 75. That is not my 28. So let's double check and make sure that A is actually the answer. So I'm going to take my 225, and I'm going to divide it by 5 to see what I need to multiply by. So I'm going to multiply it by 45. So if I have my 2/5 times, and I'm going to multiply it by 45 over 45, because I have to multiply my 5 by 45 to get my 225. And because it's a unit of 1, I have to also multiply my 2 by 45, and 2 times 45 is 90. So therefore, A is going to be your answer. So if you have any questions about this, please make sure you come prepared tomorrow ready to ask. Have a good day.